My name is Chandra Prakash Reddy, Assistant Professor in Physics, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. Today we are going to discuss about the fiber optics. Before going to discuss about the fiber optics, what is fiber optics? We have to know about what is fiber optics. Optical fiber is a flexible transparent fiber made of glass or plastic slightly thicker than human hair. Then coming to the optical fibers, optical fiber having many advantages in a communication system. Then it can function as a waveguide. It can function as a waveguide means then it acted as a guiding media for light signals. We already know to transmit any type of data. We required one guiding media. That guiding media here, for example, to transmit the electrical signals from one place to the another place, we require copper cables. Like to transmit the light signals, here optical fibers are using as a guiding media. Then instead of that, optical fiber cables having many advantages over the coaxial cables. Then before discussing about the advantages or before going to start about the construction and principle of the optical fiber, I am giving only two advantages. Later we are discussing about the advantages in the lateral classes. Now I am giving only two advantages of optical fiber cable over the coaxial cables. Optical fiber cables having high bandwidth. Due to his bandwidth will be 10 power 15 gigahertz. The bandwidth of the optical fiber cable, bandwidth nothing but frequency of the optical fiber cable is about 10 power 15 gigahertz. Due to its bandwidth, it having high information carrying capacity. So that is the main advantage of optical fiber cable over the coaxial cables. Then instead of that, then data loss also very less. Without using any repeaters, data to be transmitted over the kilometers also without data loss. So these are the two main advantages of optical fiber cables. That's why optical fiber cables, these cables are replaced with the other cables in a communication system nowadays. That is the main advantage. Now I am starting with the construction and principle of the optical fiber. Before introduction, see the slides once. Power over the fiber optic cables can also work to deliver an electric current, flow power electric devices. So optical fibers are widely used in fiber optic communication, where they permit transmission over longer distances. So these are the advantages. Then coming to the structure of an optical fiber. Before the structure of the optical fiber, then it have three sections mainly. At the center part, we have a core material, and this is the core material. Here core is surrounded with the cladding. Core is surrounded with the cladding. This is cladding. And cladding is surrounded with the protective layer. This is called as buffer. We call as protective layer also. So three sections in main construction of the optical fiber. One is the core material. This is totally core material. Total data transmitted to the core material only. Here core and cladding both are made up of with glass or plastic material. So in the refractive index of the core material. So the core refractive index we are taken as small n1. Cladding refractive index will be n2. The refractive index of the core is slightly greater than to the refractive index of the cladding. See, then in the construction part, in the structure of the optical fiber, we have mainly three sections. The three sections are, one is core, second one is core is surrounded with the cladding, then cladding is surrounded with the protective layer called as buffer sheet. Then the refractive index of the core material is slightly greater than to the refractive index of the cladding. Why? Because to satisfy the construction of to satisfy the principle of the optical fiber cable. We know the principle of the optical fiber cable is total internal reflection. So I am drawing again construction of the optical fiber. So this is a core material. This is called as core. Your core is surrounded with the cladding. Core is surrounded with the cladding. Cladding is surrounded with the protective sheet or buffer sheet. We call as outer jacket also sometimes. So your core refractive index we are taken as N1, cladding refractive index is N2. To satisfy the condition of total internal reflection, N1 is refractive index of the core is always slightly greater than to the refractive index of the cladding. Why? Because we are discussed in the construction of the in the principle of the optical fiber. You can understand very easily at that time. So this is the structure of the optical fiber. So the diameter of the core is about 7 to 10 micrometers. The diameter of the cladding is 125 micrometers about. Then buffer or outer jacket is about 185 to 700 micrometers sometimes. So the structure of the optical fiber having core material, core and cladding and coating or buffer or outer jacket. These are the three sections in the structure of the optical fiber. Coming to the core is a cylindrical rod of dielectric material. Light propagates mainly through the core material only. Total data in the optical fiber, total data is transmitted through the optical fiber only. So the core is made of a glass material. So high refractive index. Already we discussed about the refractive index of the core and cladding. Then compared to the cladding refractive index, it having high refractive index. This is a structure again. Cladding. About the cladding, the core is surrounded by a layer is called as cladding. That is also made up of with glass or plastic material. Then the refractive index of the cladding is slightly less than the refractive index of the core. Then performs the following functions. This cladding is performs some functions here. So light reduces the loss of light. Then first thing is reduces the loss of the light, reduces the scattering loss, and protects the fiber from absorbing surface containments. Then last thing is adds the mechanical strength. Mainly it protects it reduces loss and it produces mechanical strength to the core material. So coming to the buffer is a plastic material. So from the physical damage to protect from the physical damage, then we are using buffer. Then buffer usually used as a plastic material. These are the three sections available in the construction of the optical fiber. So again, in the construction we have mainly three things. One is core material, second thing is cladding and cladding material, third one is buffer or outer jacket. So both the core and cladding, both the materials made with the glass or plastic material. The refractive index of the core is slightly greater than to the refractive index of the cladding because to satisfy the condition of total internal reflection. So third thing is buffer. Then buffer is used to protect from the physical damage. So this is about the structure of an optical fiber. So coming to the now principle of the optical fiber. Now going to the principle of the optical fiber. Then due to total internal reflection, here principle of the optical fiber, light carries through the optical fiber cable or through the core material by the principle of TIR. TIR nothing but total internal reflection. So coming to the total internal reflection. To get the total internal reflection, then light ray should satisfy the conditions, two conditions. First thing is it traveling from denser medium to rarer medium. Second thing is, the angle of incidence is greater than to the critical angle. When the light ray satisfies these two conditions, then total internal reflection takes place. So coming to the total internal reflection, here principle of the optical fiber is TIR, TIR, TIR nothing but total internal reflection. Coming to the total internal reflection, to get the total internal reflection, light ray satisfies the two conditions. So for suppose these are the two mediums, this is a denser medium and second one is rarer medium, and this is the normal to the two mediums. When the light ray traveling from higher denser medium to lower denser medium, nothing but denser medium to rarer medium, then what is the nature of light? The angle of incidence, this is the light ray, this is called as angle of incidence. Angle of incidence is less than the angle of refraction, this is called as R, angle of refraction. So I is always less than to the R when the light ray traveling from denser to rarer medium. So it is not a total internal reflection. To get the total internal reflection, this light ray should satisfy the second condition also. What is the second condition? The angle of incidence is greater than to the critical angle. The angle of incidence is greater than to the critical angle. So coming to the critical angle, for suppose I am increasing the incident angle, so I am increasing the incident angle here, then corresponding refraction also increases. Then at a particular angle of incidence, what we are going to observe? Light ray, refracted ray travels, grazes at the surface of the two mediums. So then the angle of incidence, this angle of incidence we are calling as critical angle. This angle we are calling as a critical angle. Usually we are representing with theta c, critical angle. Then after the critical angle, further increasing on incident angle, what we are going to observe? The light ray reflected back into the same medium is called as total internal reflection. That's why to get the total internal reflection, light ray satisfies the two conditions. First thing is, then it should be travel from denser to rarer medium. So second thing is, angle of incidence is greater than to the critical angle. This is the second one, this is not second one. Then when the light ray is traveling from denser to rarer, what is the nature of light? The angle of incidence is less than the angle of refraction. So in this case, we won't get the total internal reflection always. When the light ray satisfies the condition, second condition, that is I greater than to the critical angle, means incident angle is greater than to the critical angle, then only we get the total internal reflection. So coming to the slides, so optical fiber carries the light from one end to the another end by the principle of total internal reflection. When a ray, then here three diagrams represents the same thing what I am explaining. So when a ray of light passes from optical denser medium to optical rarer medium, the refracted ray bends away from the normal. So this is a, again I am the, this is a normal, this is a denser medium, and this is the rarer medium. Denser medium, rarer medium. This is a incident ray. Incident ray. This is called as angle of incidence. Angle of incidence here when the angle of refraction. When you observe, the angle of incidence is greater than less than the angle of refraction. In the second diagram, then in the first diagram you can observe very clearly. So in the second diagram, angle of incidence increases. Some of red color arrow marks indicates angle of incidence. That angle of incidence, then here compared to here, the angle of incidence is greater. So in that case, light ray, refracted ray travels at the surface of the medium, then and makes an angle 90 degrees here. So that is this angle I am calling as critical angle theta c. So where the refracted ray grazes at the surface of the two mediums, that angle of incidence we are calling as critical angle. So after the critical angle, in the third diagram, then after the critical angle, what we are going to observe? Then light ray reflected back into the same medium is called as total internal reflection. That's why this is the condition to get the total internal reflection. Second condition. In the three cases, in the three diagrams, then light ray traveling from higher denser medium to lower denser medium to rarer medium only. That is the first condition. In the three diagrams, first condition is always satisfied. So coming to the second condition, in the third diagram only, then second condition is satisfied. That's why there we are getting total internal reflection. That is the principle of the optical fiber cable. Then by the total internal reflection, maximum data to be carried by the optical fiber cable. So there is a main advantage. That's why in the communication system, all the cables are replaced with the nowadays. All the cables are replaced with the optical fiber cables. So for your reference, take the three diagrams. Already we referenced the three diagrams. No need to worry. Remember the two conditions to get the total internal reflection. Now what are the two conditions? Light ray should be travel from denser to rarer, optical denser to optical rarer medium. And second condition, what is the second condition? Angle of incidence should be greater than to the critical angle. Coming to the critical angle. So critical angle, when the angle of incidence is increased, angle of refraction also increases. So at a particular angle of incidence, what will happen? Light ray, refracted ray travels at the surface of the two mediums. Then that angle of incidence we are calling as a critical angle. So further increasing of incident angle, we get the total internal reflection. That's why to transmit the data through the optical fiber cable, so we have to launch the light above the critical angle. Then only light ray traveling through the core medium by the total internal reflection. This total internal reflection I am showing here the diagram. When the light ray traveling from an optical denser medium into the optical rarer medium, is incident angle is greater than to the critical angle, then the light ray totally reflected back into the same medium is called as total internal reflection, and it obeys the laws of reflection also. That is the laws of reflection. The phenomena is known as total internal reflection. Here representing the same diagram also. These three layers, three rays are obeys the conditions. That's why it get back into the same medium by the total internal reflection. That's why maximum data also to be carried by the optical fiber cable. Again, once again, see the construction structure having three parts: core, cladding, and outer jacket or buffer. Core and cladding made with the glass material. The refractive, that's why in the manufacturing part we made the refractive index of the core is slightly greater than to the refractive index of the cladding. By making like this, then it is always act as a denser medium. Core material is always act as a denser medium. Cladding is acted as a rarer medium. That's why N1 both material made with the glass or plastic material only, but the refractive index is slightly differ with the core to cladding. Always N1 is greater than to the N2. Why? Because to satisfy the condition of total internal reflection. This is about the structure. Coming to the buffer again. Buffer is used to protect from the physical damage, and these three diagrams represents the principle of the optical fiber. In the first diagram, that is we get partial reflection. There is not a total internal reflection. In the second condition, refracted ray grazes. That is called as a critical angle. Then angle of incidence we are calling as a critical angle. In the third case, we get the total internal reflection when the light ray incident greater than to the critical angle. I is greater than to the critical angle. So we get the total internal reflection here. Usually I am indicating with I, but here representing in the diagram representing with theta. No worry. So this is about the principle and construction of the optical fiber cable. In the next class, we are going to discuss about we are going to discuss about acceptance angle and numerical aperture of the optical fiber cable. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.